Hey everyone, this is Math Sky Channel here, and today we're going to be going through composite functions and functional equations. So just moving on from trigonometric equations now. So a composite function is kind of the best way to put it is when the output of one function becomes the input of another function. And at first that kind of sounds weird. So just let me explain. So let's say, for example, you have two functions. Here, for example, f of x equals x squared, and g of x is 3x minus 1. And most of the examples I'm going through will be from the textbook I've used as a resource, which is the Jacaranda 6th edition, I believe, for the 2019 study design, for the VC. This notation, so f of g of x, so fog, which you may have seen memes across on the maths pages if you've seen it, but that means that's a notation for f of g of x inside, and g of x is 3x minus 1, so that'll be f of 3x minus 1 equals 3x minus 1 all squared equals 9x squared minus 6x minus 1. So it turns, if you look at the thing, the domain of f of g of x is the domain of g of x, which is r. And I'll get back to later as to why that's the case. Then we do the opposite around g of f of x. So you have g of f of x inside, that's g of x squared. That becomes 3x squared instead of x minus 1. So you just get 3x squared minus 1. And the domain of g of x is the domain of f of x, which is also the real numbers. Usually when you have composite functions like this, in the case f of g of x is pretty much never equal g of f of x. I don't remember a case where that I can't recall when that is the case. But you know, even if the function is the same, it might have a different domain and range. But anyway, we'll have a tangent there. So for if you've noted, I've closed this earlier, but for f of g of x to exist, the range of g has to be within the domain of f. That's the wrong notation. The either, but I think you get the idea. And for same vice versa, for g of f of x to exist, the range of f has to be within the domain of g. And if you look at the functions f of x and g of x, that's the domain. So the x values you can take, and the range, the y values you can take. You can see that these rules are satisfied. And moving on here, functional equations, and it's just seeing if some functions satisfy certain rules. For example, if f of bracket x plus y equals f of x plus f of y. So for example, if f of x equals e to the x, something we haven't done before, but it's relating to exponents. You may have seen this last year when you're doing things like half-life, exponential growth, decay, that sort of thing. But in the question asks you, for example, to investigate if f of bracket x plus y equals f of x times f of y. And what you do is you substitute e of x into both parts of the equation. So you have here, the first example, f of x plus y. So e, the power becomes x plus y here, and f of x times f of y becomes e of x times e of y. And when you're multiplying exponents, the exponents add. So you have bracket e raised to the power of x plus y, and these two are therefore the same equation. E of x satisfies this rule. Mostly if you're going through tests, especially through trial and error, and you have a multiple choice section, you probably do this for trial and error, honestly. Unless it's in the rare instance where you can look at it and immediately tell. But otherwise it will be mainly trial and error. Yeah, that'll be all.